So we saw already that the definite integral gave us the area between the curve and the x-axis. We've seen some properties. We saw that when the area was below, it was negative. So we're going to just play around with that a little bit today and do some more stuff with that. Because sometimes you get specific questions that say, find the area enclosed by the line, the x-axis, and the lines x equals 1 and x equals 5. So if we draw a quick picture of what's happening here. 2x minus 1, well, that's a straight line with a slope of 2, a y-intercept of minus 1. And if we were finding it between the lines x equals 1, and x equals 5, and the x-axis, pull out a crayon. Let's go purple. This is the area that we've been asked to find. So we notice that the entire thing is above the x-axis. We don't have to worry about some of it being below the x-axis. So now to calculate that area, all we have to do is find the definite integral from 1 to 5 of two x minus 1 dx. My fancy pen, you like it?
That's scary. It looks nice.
I know, my writing looks so bad, now it looks so nice. Yeah, you click under Make Your Teacher Look Better pen, and you click on that one. So then, just mesmerized by the pen. I have no idea what's happening mathematically anymore. I'm just watching the pen.
As long as it looks good.
That's exactly it. That's half of math, as long as it looks good. So plug in the 5, plug in the 1. And we get an area of 20. So again, since the whole thing was above the x-axis, the 1 to the 5 set our lower limit and our upper limit. We drew a sketch of it, and then we could just find the definite integral from 1 to 5. Find the area enclosed by the curve 15 minus 2x squared, and the lines negative 2 and 2. So again, we're going to want to make a sketch of what's happening. 15 minus 2x squared. That's going to have, it's going to be a parabola that opens down. It's going to have a vertex at 0, 15. And the question is, where are these x-intercepts? Because those x-intercepts are where things go into the negatives. And so if I set y equal to 0, I'll put the 2. So x is going to equal plus or minus the square root of 7.5. What's important about that is not that we can do that with mental math and know what exactly the square root of 7.5 is, but what is important is that we know that that number is bigger than 2. Square root of 4 is 2. And that's important in this case because we're asked to find from negative 2 to 2. So if those are our lines, take out crayon, that's the area we're going to find. Again, none of it's negative. So when figuring out what that area is, we can find the integral from -2 to 2 of again, this is an easy integral. Add 1 to the exponent, divide. So just putting like terms together, 30 plus 30, that'll be 60. Negative 16 over 3 minus another 16 over 3 minus 32 over 3. So this will give us a final answer of 148 over 3. Again, if you wanted to, you could graph this into your graphing calculator and check that value to see if that value is correct. So each of these ones so far have been straightforward in that the area has been nice and completely above the curve. Find the area between the curve y equals cos x plus 1. So again, what does cos x plus 1 look like? Well, our cos graph shifted up 1. Our sinusoidal axis would be here. We're graphing it from 0 to pi, but as far as graphing it goes, I'm going to graph it between 0 and 2 pi. Cos graph starts at a maximum. There's your graph of cos of x moved up 1 unit. We want to find the area from 0 to pi. So as far as our shading goes, that's my best crayon coloring I've done in a long time. That's what we get. I think that's a really nice area to try and find because there's lots of curves all the way with it. So as far as figuring this out, we have our integral from 0 to pi of cos x plus 1 dx. What's the integral of cos? Negative sign? Positive sign? Positive sign. Plus x from 0 to pi. FLIPEROO and it's just pi. Yeah, that's all you have to do. A little, yeah, flipper, right? Plus pi sine of 0. Oops, easy. Okay, and FLIPEROO gives us pi. Well, what's sine of pi?
0.
0. Plus pi, pi. Minus sine of 0 is 0 minus 0 pi. Okay. Right. So accordingly, apparently, if you want to take that shortcut and go directly to there, you need to make sure you write FLIPEROO. Is that the correct spelling?
I put 2 P's, but that works.
Okay, that works.
So where does the FLIPEROO happen? Exactly.
What is the FLIPEROO? Is this on a journey through your mind?
So if you have a function that's below, then if you wanted to find the area between the curve, when you do the definite integral, it'll come up negative. So to counteract that, we could just do absolute values around that part, and then that will actually give us the area between the curve and the x-axis. Right? So let's look at this one that we've done, that graph we've done before, 2x minus 1. There's our line. And now we want to find it between -4 and -1. So this area, when we find it, it's going to be negative. I should have done red for negative. Oh well. Oh, maybe we can change it. There. You want magenta? Like it's in the negative. It's in the red, right? This is the right color to you. I know, but is that this is? Oh. Ooh. Ah.
It's to the left,
Ee.
that one. Oh, one to the left.
Not that left? The thickness of the crayon? It's, yeah. Ooh!
That's just the savage.
Yeah. Okay. Nice. Let's just admire the crayon for a second. Okay, there we go. Are we ready? So now, pull out our fancy pen. Fancy pen thick this time? All right, from -4 to -1. It's a straight line and it's blue. It looks like a cucumber. Those are good quotes. This one particular. This definitely not a cucumber. Yeah. Okay. So we've already figured out that this was, whoa, just x squared minus x from -4 to -1. I find with the negatives is where you're going to be like, oh, I thought I knew which one to plug in first, and now I don't know. Because when you're going from 2 to 5, it's easier to think, oh, I'll plug in the big one minus the small one. But sometimes with the negatives, you're going to get that mixed up. So it's always your top one, 1 minus a -1. That goes in first, and then your bottom one. So it'll be 16 minus a -4. And when we do this, we're going to get 2 minus 20. We're going to get -18. So that -18 represents that that is below. And if you're doing a question like this that says find the area enclosed by the line and the x-axis, make a sketch, and you realize I've got a negative answer in the end, it's supposed to be +18 as my answer, I should have absolute value bars. So I'm going to use green for these straight lines. So you can just put absolute values all the way around it and get your right answer in the end. So we've had some questions that were only positive, they were easy. Some parts where the area was only negative, we could just take the absolute value. But we haven't done any questions which say find the area between the curve and the x-axis where part of it's positive and part of it's negative. When we did the definite integral before, I think there was one where a cos graph, and the answer was 0 because it canceled out. But there's actually an area below and an area above, and if you wanted to find the area between the curve and the x-axis, you'd have to add those two parts together. So how do we do that? Well, we have to figure out the different sections, and those different sections are going to be based on where those x-intercepts are. So we need to find our x-intercepts, then separate our integral into two different parts. One part will be negative, one part will be positive, and find each of those separately, and then we can add them together. So x squared plus 4x. Graphing x squared plus 4x. It's a parabola. It's a parabola that opens up. You can factor that quickly and easily to find your x-intercepts. So we find out we have an x-intercept at 0 and an x-intercept at -4. So here is our parabola. We want to find the area between -2 and 2. So as far as coloring this, we'll have this red section that's negative and this black section that's positive. So when we want to find the total area between the function and the x-axis, we're going to have to make sure that that red one and the black one are done separately. One of them is going to be negative. One of them is going to be positive. It's obvious from your graph that the red one's negative and the black one's going to be positive. So when we separate this up as our integral, we're going to have the integral from -2 to 0, because that's where our x-intercept is, of x squared plus 4x dx, plus our integral, whoa, that's a thick one, from 0 to 2 of x squared plus 4x dx. What do we need to do to our red one? Add absolute value bars around that one, because that one's going to be negative. So our red one, we're going to have x cubed divided by 3 plus 4x squared divided by 2 from -2 to 0. Plus same integral, x cubed divided by 3 plus, I'm just going to simplify this to 2x squared already, from 0 to 2. And this one needs absolute value bars around it. You okay with those bracket ideas there? And I got the absolute value bars around it. It's going to get a little bit long here, and then we're going to simplify things. So plugging in plugging in 0 first, we're going to get 0. Guess I didn't quite need all that space in that brackets. Here, plugging in -2, we're going to get -8 over 3 plus, this is just going to be 2 times 4, 8. Over in the black section, plugging in 2 will give us 8 over 3 plus 8. And plugging in 0 will be 0. Simplifying inside, we're going to get a negative number here. We are going to get, this is 24 over 3, 16 over 3, negative 16 over 3. And over here, we're going to get 32 over 3. Now we can take the absolute value, make this positive, and we get 48 over 3 is our answer. All right, I'm going to get you to try this one. It's recording now. Make sure you sign in calligraphy pen. That's not a calligraphy pen, but
Yeah, it is.
no, it's not.
Oh, is that regular? Where's the calligraphy? Okay, where am I gonna do this? Can I do it? I'll do it.
It'll be a video called FLIPEROO. That picture's
Oh yeah, I have to add FLIPEROO. I forgot about that.
I've never been more motivated to do math in my life.
Can this be the thumbnail?
It might be. That's what I'm saying. If I record this long enough. Okay, here we go.